Assalamualaikum warahmatullahi wabarakatuh and good evening everyone. I think we have one participant from Japan. It looks like that we have to use English 100%. Oh, from Masa as well. Alright, okay. But you can understand Malay and Indo, right, Prof? You can also understand Malay and Indonesia. Cannot.
You're waiting for new dean now?
Sorry, Prof?
You are waiting for the new dean.
Waiting.
Yes.
So maybe Dr. Azna or Dr. Kamaru, perhaps?
No. A new one will be coming.
I'm also excited, want to know who will be our dean.
Oh, okay. And let Dr. Nurul Rahma and Dr. Fatiha.
Usually the common practice TDA will be the most suitable. I mean, the positions after the TDA usually will become a dean lah. That is the most practice in UTM lah.
Okay, it's about time, so I'll be quiet and I can be here.
Yeah,
only in
it's already
30
2
minutes.
o'clock.
Sorry,
I think it's better we start so that we can finish as well on time. All right, so Assalamualaikum warahmatullahi wabarakatuh and good afternoon, everyone. So I am Dr. Azna Noor Anwar, Deputy Director of Dppc, Disaster Preparedness and Prevention Center of Malaysia Japan International Institute of Technology, University Technology Malaysia Kuala Lumpur will be the MC for today's session. So I would like to welcome everyone actually for today's Dppc webinar session with the title of Experience in Utilizations of X-band Polarimetric Radar for Disaster Risk Reductions. Okay, before we start, I am happy to highlight the today's webinar aims, which is we are able to build scientific knowledge, innovations and educations networking in disaster science and technology applications, to share experience from international experts, specifically in utilizing XBP radar for disaster risk reductions, and to understand regional issues and global challenges related to the utilizations of XBP radar as a cost-effective solution for preventing future risks. And okay, why we choose today's topic for informations. Early this year, I think the Dppc have completed installing the X-band radar at one of our campus, which is located in Pago. And starting from there, we are now start exploring the benefits of this X-band radar, okay, for the disaster risk reductions. And today we are very fortunate, okay, to be able to have our expert from Indonesia, which are also experienced utilizing this XBP radar for the disaster risk reductions. So thank you very much and welcome to our guest speaker, Professor Engineer Dr. Adam Pamuji Rahajo from the Department Teknik Sipil dan Lingkungan Fakultas Teknik Universitas Gadjah Mada, Indonesia. And also our second speaker, Dr. Santosa Sandiputra from Balai Teknik Sabo, Kementerian Pekerjaan Umum dan Perumahan Rakyat Indonesia, which I was informed if in Malaysia is actually equivalent or similar to our Jabatan Pengairan dan Saliran JPS or DID in Malaysia. Okay, and also we are also would like to thankful to our associate fellow Dppc, Dr. Noradila Abu Hassan, which is also experienced utilizing this XBP radar during her study, her PhD study. Okay, under the supervisions of the Japanese professor, which I know that Prof. Masa is one of the supervisor. Okay, Dr. Noradila Hassan will be the moderator of the sessions. So before we start this session officially, before I pass to the moderator, so we are also would like to thankful to our director, which is Dr. Kamarul, okay, to be able to spend your time, okay, for today's sessions. And we would like to hear actually a few words from you, Dr. Kamarul. Okay, before we start the sessions, without further ado, I would like to welcome our director, Dr. Kamarul, to say a few words before we start the sessions. Okay, so over to you, Dr. Kamarul.
Thank you. Thank you very much, Dr. Azna, Deputy Director of Dppc. So on behalf of the organizer, we once again would like to welcome everyone, especially our sensei, Goto Sensei, who are joining us from Japan. Thank you, Professor Masafumi Goto, for joining us today. It was a great pleasure to welcome everyone. Thank you very much to the team led by our Deputy Director, Associate Professor Dr. Azna today. So once again, this is one of the platforms where we gather the experts at the region level. And thank you once again, Professor Engineer Adam Famuji. It's a long time no see, Professor. Terima kasih Pak Adam dapat bersama-sama hari ini. It's our pleasure to welcome our partner from Universitas Gajah Mada Indonesia, one of the strongest ally so far in the region with respect to the disaster risk management. And not to forget our partner, Dr. Santosa Sandy Putra from Balai Teknik Sabo, Indonesia. I was very fortunate to have you here today to be in the session because we were out of the campus for a couple of days, and now we are happy to see you, to welcome you to our platforms. As mentioned by Dr. Azna, this is one of our commitments to provide platforms to share views at the regional level on how we can advance the new technology, particularly dealing with these polarimetrics or X-band radar system. As you may notice that Malaysian governments, through a new Look East policy, we have engaged many partners, particularly from Japan, to invest into the new technology. And I'm very proud to mention that this is one of them. Yeah. So after a series or a couple of years of reviewing, understanding the needs and demand, and luckily we have installed the first ever X-band polarimetrics radar in Malaysia. And I believe that this system was not mainly used for disaster risk reduction, disaster risk management, particularly on forecasting, nowcasting, and predictive, but also it provides a new added values to the current system. For your information, I think it's worth to mention that through these platforms, we have also engaged many national stakeholders. One of them is Department of Irrigation and Drainage. And through our engagement with Praban, this National Forecasting and Early Warning for Floods, one of the major stakeholders who could also benefits from this system. And through our engagements, we understood that there are many rooms of improvements on the current modeling and parameterizations. So this is one of the particular elements of improvements into the current system established by the Malaysian governments. And the second stakeholders that we have engaged so far is Malaysian Meteorological Departments, MMD or Met Malaysian here. So Met Malaysian also have expressed the great interest on how we can tap the S-band radar data into the current forecasting and nowcasting for the extreme weather event. And as you mentioned, that the recent report released by the World Bank and Bank Negara, our national federal bank, recently mentioning that Malaysia is among the top 10 in the world in terms of the floods frequency. So I think by investing into the new technology, we understand the importance of build so-called regional partnerships, to really understand the advantages and disadvantages of the system. So we are pleased also to welcome our strong partner from UITM, Seremban. Thank you, Dr. Nuradila Abu Hassan. And I'm also happy today to see all familiar faces. And definitely, there are many more will be coming. Don't worry. I think we have to give some time for the stakeholders to join our platform. And I would like to take this opportunity to thanks to our men and women behind this event. Thank you, Islah. And we have Ain here, Farahani, and together with me, we have Akila and Nora, and not to forget our strong ladies, Kamalia and the teams at the DPPC level. So once again, I would like to welcome everyone to this multi-transdisciplinary platforms. Please use the platforms to communicate, learn something new, and inform others that through this technology we can improve our current understanding. But not to forget that this platform will be not the first and the last one. We welcome any new ideas for collaborations, any rooms of improvements of the current system, and definitely this platform is one of the many so-called Sendai 2030 DPPC webinar series. Is our long-term commitments to UNDRR Sendai Framework for Disaster Risk Reduction 2015-2030. There are 5 to 6 years to go, but definitely these platforms led by DPPC, MGIT, UTM will allow you to get more insight into the current technology and improve our understanding. So with that, I think I would like to welcome everyone once again for those who just joining us session today, and definitely please disseminate the informations to others who are not able to join. So that's it from me. Enjoy your sessions and have a great day, everyone. Over to you, Dr. Azna.
All right, thank you, Dr. Kamarul, for your kind welcoming remarks. Yes, we actually really appreciate our speakers from Indonesia, their willingness to spend their time. And we actually look forward for more future collaborations after this, especially in this X-band radar utilization. And we actually invited our dean, and also Deputy Dean, all the top management also would like to welcome you, Prof. Adam, and also Dr. Sandy, but I'm sorry on behalf of the MIT top management, due to their unavailability. Okay, like our Dean is actually just appointed as Deputy of Vice Chancellor. Okay, our Academic Deputy Dean is away. Thank you very much. And before I pass the sessions to Dr. Dila, I hope that we still have time for me to share actually the hard works of the DPPC team since this X-band radar was installed. Okay, so they provided a video to highlight all the hard works that by the DPPC team. Without further ado, maybe I would like to invite Isla to play a video just sharing with everyone regarding our X-band radar located at Thank you. All right. So this video actually highlighted our engagement with the local stakeholders, and today is actually our today's is actually remark our first engagement with the international experts. So thank you very much again, Prof. Adam and also Dr. Sandi. Okay, now I would like to pass the sessions to our moderator, Dr. Dila. So the session is yours, Dr. Dila.
All right. Thank you, Dr. Azna. Can you hear me clearly? Yeah. All right. Assalamualaikum and good afternoon, everyone. Welcome to our sessions on experience on utilizations of X-band polarimetric radar (XBP) for disaster risk reductions. My name is Dr. Adila binti Abu Hassan, assistant member of Dppc, and I will be your moderator for these sessions. We have gathered here today to discuss the significant advancement and experiences in using X-band polarimetric radar technology to mitigate the risk associated with natural disaster. The XBP radar generally used for volcano ash and rainfall monitoring. This technology has proven to be a valuable tool in enhancing our ability to predict, prepare for, and respond to various disaster scenarios. Before we begin, I would like to introduce our distinguished speaker who bring a wealth of knowledge and experience in this field. The first speaker, as we know, is Professor IR Dr. Adam Pamuji Rahatjo from Department Teknik Sipil and Lingkungan Fakultas Teknik, Universiti Gadjah Mada, Indonesia. A brief details about his background. Actually, he's graduated from UGM in 1995, major in hydraulic and hydrology, and he further his study in master program in field of coastal estuary and river engineering at Imperial College 1988, and completed his doctoral program in finite element methods of riverbed dynamics at University College of Swansea, University of Wales in 1991. Since then, he pursued the field of numerical simulations and measurement instrumentations of river dynamic and sedimentation, especially those related to flood disaster mitigations in the form of inundation, flash flood, or lahar flow attacks. And currently, he serves as professor in hydroinformatics, covering the developments of debris flow models, hydrometric telemetric system, and other related subjects. He also appointed as secretary and then chair of Natural Disaster Management Engineering Master Program since 2017, which has collaborated in education and research with several domestic and foreign institutions in the field of natural disaster. Welcome, Prof. Okay, our second speaker is Dr. Santosa Sandiputra. He's from Balai Teknik Sabor, Kementerian Pekerjaan Umum dan Perumahan Rakyat Indonesia. A brief about himself: he graduated Civil and Environmental Engineering from UGM 2008 and completed his Master of Science from UNESCO IHE Delft, Netherlands 2014. And he received his PhD from University of Leeds 2022 with the research the impact of peatland restoration practice of hydrological function in tropical environment. He is actually a researcher in hydroinformatics, water science, and engineering since 2009. And actually, he deals with modeling, optimization, and control of water systems. Okay, so without further ado, I think we begin our session with the first question to Prof. Adam. So, Prof. Adam, do you mind, or would you elaborate on how this X-band polarimetric radar can be utilized specifically for disaster risk reduction from your experience as academicians? So, Prof. Adam, please.
Okay, thank you very much, the moderator. I like to appreciate this organization of the webinar, especially for Dr. Kamarul, the director of Dppc, and also Dr. Asna. Maybe I will take this opportunity to share our experience in dealing with the radar that was installed in 2019, but unfortunately, there now is no work for us. Let me share the PowerPoint that I have prepared. It's Sorry, have to show the screen.
Yes, Prof, we can see your screen.
Okay. First of all, I'd like to share our experience in using Expand. In our case, the radar is Expand multi-parameter dual polarization. I don't know whether this is the same, exactly same with the one that
Yeah, it's the same.
Malaysia.
It's just different versions of radar, but it's the same.
Okay, it's the same, yeah. So, okay, there are 3 case studies that I will share in this presentation. The study will present works of academic staff and students in the hydraulic laboratory of the Department of Civil and Environmental Engineering. Actually, I invite also Dr. Rahmat Jayati, who was the radar data and other study. I don't know whether this one already in presentation mode. It already in presentation mode?
No, but
Oh, no.
but I think it's okay in this one because I'm scared it will takes lots of data, so it will lag your screen.
Okay. Okay, this presentation is organized in 3 parts. The first is the location of radar station and a case that using GSV and TIFF and also GPEG data for nowcasting. And the last, I will share 2 research using binary data for 3D raindrop distribution analysis. The next slide here is the then MP radar location. We install close to the Merapi radar. This because at that time one of the professors in Japan would also use for monitoring the volcano ash. So it is located in close of the Merapi crater, and the elevation is about 742 meters above sea level. The next is one. I'd like to, maybe this is similar or no, the X-band ambulator use the frequency of 9,470 megahertz, or and with the beam is 2.7 degree, but the resolution is 0.1 degree, and it has the PPI, plan position indicator mode, can 360 degree with 968 azimuth and at 9 angle, and the maximum range is 30 kilometers. The pixel data that is outputted by the system is 150 and 150 square meter. And later on, we recognize that the data in the pixel is come from the Cmax data, maximum of vertical column. Our study in nowcasting using the extrapolation method, what is called optical flow method, that was done by PhD students, Robi Hambali, under the supervision of Dr. Lakono and Dr. Ahmad Jayati. And the research utilized the CSV, TIFF, CPEG data that was actually image data, and that image data transfer back to the raster value of the rainfall, and then was analyzed to get the pattern of the velocity, and then it can be used for now. This is the picture of consecutive images that were used by the researcher that used the high resolution quantitative distribution nowcasting, and it used the pyramid Lucas and optical flow method. Okay, I think we can see that the picture show the development or decay of the raindrop intensity time by time in this research. Even though the radar gives 2 minutes interval, and then in this research some I think five picture is then average to get 10 minutes interval to pair with the automatic rainfall recorder data that use 10 minutes interval. Then using the same interval, the radar data can be calibrated using the ground station data, and then used for further analysis. We can see here that two consecutive data used for creating the arrow of movement of the raindrops. Actually, the dynamic of raindrop not only convection but of growth and decay, and also the diffusion. But in this case, the method simplify as a convection only. And then after having estimate of the flow factor, and then the next 10 minutes can be casting or estimated, and then we can get the next 10 minutes distribution of raindrop before it will happen soon. And then actually it was also compared with the data that is received, but I'm not included in the slide. And the second research we will share for the audience, we also use the binary data, .stn data, that also produced by the radar, and we can see the polar coordinates of the data, azimuth, tilt, and range, or called PPI, and here we then try to transform it to a three-dimensional grid or CAPI, and we use interpolation method. Here you can see that the actual data that is collected by the radar is in rays of raindrop intensity array. So we can see here on the left picture, this is one of rays of the radar pulse direction, and there are data each has range interval of 100 meters, and in here the size of the circles represent the intensity of the raindrops. And in this condition, we can see the data that are close to the radar as very dense location, but in the range of 30 kilometers away become the rays become far apart, but the 100 range for each ray is still there. For patient to make the data in form of the grid, we use two interpolation methods. One is near neighborhood, and the other is the inverse distance method. See that we actually consider data of the ray within a sphere of the grid node that we defined before, and then interpolate this, and I not but then you can see here the PPI contour of 5-degree tilt. It has wider data compared with the 18 tilt angle data. This is because that the raindrop elevation actually is about 3,000 or 4,000 and below. So for high tilt degrees, high degrees tilt, only a small area that gets rainfall data. And here we can see some problems that we faced that time, that some obstruction. Here the closest one is the Merapi Mount, and the other one, there are some highlands here that also block the radar ray. And here we can see the variation of the distance or interpolation, the size of the sphere of the interpolation here. We call here is limiting distance to consider data for interpolation. For small, too small higher value gives a gap of the contour like this, so we can compare with bigger distance limited distance, and we can have more complete like this. And then we have here just to show perspective view of a copy of Google Earth, and then here we also try to see the vertical structure of the raindrops that is captured by the radar, and then we can see finer contour can be provided with
Prof,
finer grid, right? Hello?
Prof, sorry for disturbing. You have 1 minute left.
Okay, let
Okay.
me
Right.
go faster, and then we can see here the presentation in both copy and also PCAT system, and then here, sorry, we have also three-dimensional presentation of the PCAT and copy, and I think I will show the animation of the three-dimensional. Like maybe this is the last. I think. Sorry. It's oh, this one. fix. Okay, this is this.
Yes, it's playing.
So by having this, actually displaying. Okay, can you see? So here we can see the structure of raindrops. Hopefully, with knowing this, if we can watch the rainfall on at the time, so we can give warning qualitatively when there will be a very density of rain. And I think I stopped this animation. It have here the correlation study. Actually, we would like to know the lag time of the data of the rainfall that raindrop, I mean, in high elevation, and then the time that available for us to give a warning before the water touch ground and flowing down. So we have this, for example, in one location, we evaluate the time series of raindrop intensity of different KP levels, and then we try to get the maximum correlation between different KP level, but also different location, because we consider both the wind speed and also the drop down velocity of the raindrops. So then we get the the data, the time lag, the maximum time lag. We actually vary offset of the location of the higher level, and then also vary the time lag to find the maximum correlation. So this is the closing remarks. My conclusion is we have utilizing the X-band multi-parameters radar, and it's needs understanding what really sensed by the system. In our research, we used still only one parameter, that is the raindrop density, and there are other parameters such as the Doppler velocity data. However, this Doppler velocity data only measure the radial velocity, so it needs more radar device to get the actual velocity. So maybe in this time we have only we can compare the velocity that is recorded, the radial velocity, and the change of the radar raindrop images between 2 or 3 images. And the necessity in considering 3D structure of raindrop in nowcasting is we consider is very important. Understanding this matter may lead to a better flood early warning. Thank you very much for your attention. Sorry if
Right. Thank
very
you,
simple things.
Prof. Adam. It's a very informative information you shared just now. Okay, for the participant, if you have any questions, you may drop in the chat box, or perhaps we can have the question by before end the session, in the Q&A sessions. So moving on, we also I also would like to invite Dr. Sandy for the next questions, which is, would you share some real world example or case study where expand volumetric radar has made a significant impact, especially on government's point of view? Please, Dr. Sandy.
Okay, thank you very much, Dr. Dila. Just to add something to my CV, I actually forgot to mention that I was a Professor Adam student during my bachelor degree.
Oh, that's great.
Okay,
Okay,
please
good,
allow
good
me
students.
to
Yeah.
share my screen here. Share screen. Okay, so today I would like to present about the application of the expand radar in Merapi volcano area. So this presentation was prepared by me and my colleague, Mr. Ahyar Mustafa. Like that. So in my office in Merapi area, actually the utilization of radar has a long history like that. So since 1984, the Japanese researchers had already installed the radar in Merapi to monitor the rainfall distribution like that. So the things is not so quite different than today, because at that time it's only copy or one layer like that, but these days become we can see more advanced detection by 3D like that, but at least the concept is quite the same. And we also have another radar actually. So after the 2010 Mount Merapi eruption, the government installed a radar which is the type is Doppler radar, so it's not as advanced as expand radar, or at least I have to say that it has a different detection mechanism like that. But the operation is ended in 2017. And the other occasion in 2014, there is a research project called Subtrops, and it's installed radar in Merapi Museum to monitor the activity of Merapi volcano, especially at the time is about the tephra distribution, but I will explain about it later. So the main purpose was not for rainfall monitoring only like that. So scientifically, I had tried to test the quality of the data from the installed expand radar, and we found that I and my colleagues found that it has a high accuracy for light rainfall, but for higher rainfall intensity, the correlation was not so good, or at least there are different data between the radar data and the ground station like that. But the disclaimer is probably at that time we haven't implemented full radar data accuracy like that. So I just analyzed the data in the copy of 1,000 meters from the ground like that. So but the as Professor Adam had mentioned it, that it has several layers that can be analyzed as well. But at least that was I found. After that, we understand more about the radar, and I guess several other researchers can provide more accuracy in analyzing the radar data. So these are several other applications of the radar that we had. So as I mentioned before, that the main purpose of the installation of the radar is for tephra monitoring like that. So that's why it is installed in the volcanology office, volcanology museum, because we try to reach the mountain as close as possible, and also we aim to get a better tephra for mapping like that. But the expand radar has other capacity or other function to monitor rainfall as well. So the application is we can use the radar data to do pyroclastic modeling or lahar flow or debris flow modeling, and then installation of sabo dam or sediment control dam, check dam, like that, assessing the performance of that against several rainfall condition like that. And we also use it for extreme weather warning and mitigation like that. So there are other functions. And the important things is I want to also share our experience in the government. So basically, we need, based on the previous cooperation, we want to highlight the importance of cooperation between institutions like that. So as Dr. Asna has said that the installed radar will be used by several agencies like that. So based on our experience, there is an important, or there is a need of institutional setting and enhancement like that. So in this picture, for example, we want to share that we have a good cooperation with the Japanese institution and government as well. So last year, the Emperor of Japan was visiting our office, Balai Teknik Saubo. And this year, several months ago, there was a World Water Forum in Bali, and we also declare or commence the initiation of Center of Excellence for Water and Climate Resilience. The purpose is to assure that the available data can be used by many institutions that are available in Indonesia, not only Indonesia, but also we hope in the near future is for Southeast Asia as well, like that. So it was declared by the government of Indonesia. So hopefully the audience can explore further about Balai Teknik Sabo from the Instagram. And we also have several other facilities, like if I may share, we have laboratory for hydraulic, for 3D modeling, physical. We also have rainfall rain gauge installed in around Mount Merapi area. The things is there is no rain gauge of meteorological agency nearby the mountain, and the special things is our rain gauge is quite close to the mountain, so we can make a warning system or forecast with a longer lag time before the occurrence of the flood like that. And I think that's a little bit summary of my presentation. So hopefully we can have a fruitful discussion after this. Thank you very much.
All right, thank you, Dr. Sandy. It's a very brief presentations. Okay, but I do have one questions over here in the chat. Okay, I think this question I can ask to Dr. Sandy. Okay, she asked how many large area that radar cover for rainfall monitoring during your study.
Sorry, I'm still having.
Sorry. Okay,
yeah.
How large is the coverage area for rainfall monitoring in your study? I think.
Oh yeah. The radar coverage area is, I guess, around 40 kilometers or something. But as I presented in my slides, it has several blank spots. Like as Professor Adam already mentioned as well, that we cannot detect the rainfall behind the Merapi volcano. And there is also one other side in the south that was covered by some buildings like that. So it creates blank spot for the radar. So on those two direction, we cannot reach far like that. But in the other direction, I guess the coverage is around 40 kilometers like that.
40 kilometers.
Yeah,
maybe I can add.
Yes, Prof. Adam. Yes.
To answer this question, actually, as I know that this range can be set far further, more than 30 kilometers. The 30 kilometers is the setting of the X-band radar in Merapi Slough. We is considered about the beam width and the resolution of the azimuth that was set 987, like 86. So if the distance, the range set far, then we will have the farthest location has the pixel size or the rays become apart farther, and then the grid that we can make become higher. So the resolution must be coarser. So at 330 kilometer setting, so we can have 150 or 100 cell size. But if we take longer, maybe we will have a coarser cell size. So this
Okay. All right.
yes,
Okay.
yes. I think
Okay.
I think in the UTM also set 30 kilometers. Is it?
We actually in Malaysia, the coverage up to 70 kilometers.
Oh, 70.
70 kilometers, which means is cover about 4 states in Malaysia. So Johor,
Okay.
Melaka, Negeri Sembilan,
Oh,
and part of Pahang. So actually in Malaysia, we have variety of geographical locations in terms of hills, sea, city. So that's why we need to know how we can utilize the data. Okay, Prof. We do have another question. Okay, do you mind to answer this? Can you share about any early warning system that you have developed, and what is the lead time for warning? And do you use any forecasted data of yes, how much earlier the forecasted data? The early warning, the warnings. Do you have? Do you have? Or do you develop any early warning systems? And how much is the lead time for the warning by using this data?
Okay, thank you very much. Actually, our position is a researcher, not using for a public, because this is belong to Politeknik Sapu or PPTKC. So in our study for the using correlation, cross correlation study, we found that there is a potential time lag that we can get for knowing earlier the raindrop in the sky. We can have about 6 minutes, but maybe longer if the raindrop only in the high level, for example, 3,000 the sea level. But if the raindrop is lower in 1,000 or 1,050, so we can have the additional 6 minutes warning time. But the warning time also we consider the travel time, the propagation time of the water flowing on the drainage area or river catchment area and then flowing on the river. So in these things, we also study based on the record of water level in the river. So we make also correlation between the rainfall, the rainfall data from the ground station to the impact to the water level record. And actually, this depends on the location of the place that we protect from the flood. Because if we talk about protection of the area, so we need to consider where is the area and each area has different warning time. So this is the one that we need to study when we want to know the time, like certain location that we want to protect with, for example, early warning system and so on. Okay, thank you. This is my comment.
All right, thank you, Prof. So, okay, we do have the continuous questions from the first one, which is, have you done comparison between radar and rain gauge in giving alert warning system? So, Dr. Sandy, or perhaps can answer this.
Yes,
Turn on your.
actually, Professor Adam already provided good explanation about the lag time like that between the occurrence of heavy rainfall and the occurrence of flood like that. But in terms of giving the warning, so there is a special mechanism that are agreed in the area like that. So there is a paper, as I had shared in the chat. So several of our colleagues, also Professor Joko Logono, already conducted a research on how the flow of the warning system is should be followed in the area, because it would be quite strange if the government suddenly provide an alert and it was actually a false alarm, or the flood is not occurred, and etc. So as a researchers, we conducted a technical analysis, but the decision to give the alert is given to a certain agency, like the disaster agency like that. So we just informed to the disaster agency, and the disaster agency and the mayor or the governor of the area will decided whether the people must evacuate or not. There are two different types of alerts, which is the primary volcano hazard alerts, which is the tephra flow, tephra rain, and then pyroclastic flow, and etc. But for flood, usually we inform it with the local people like that. So as Professor Adam mentioned, the duration is not quite long enough like that. So we still need to increase the lag time between the prediction and the occurrence of the lahar, especially for the lahar flow like that. Thank you.
Yes. Okay, just for information, everyone, the expand polymetric radar actually can provide the data about 1 to 2 minutes. I think Indonesia also use the same format, right? 1 to 2 minutes data providing, right? So same in Indonesia. So I think we don't have much time. Okay. Okay, for those who have questions, you may write to the secretariat at the email to secretariat. So we will forward the questions to Dr. Sandy and Prof. Adan to answer, and we will get back to you. So overall, I will summarize for today's discussion. Actually, as we can see from Indonesia, there's lots of study and research we can done for Malaysia, and we can learn a lot from them, either in a private or government sector, either academic or industry player. So with the example and study case shown before, I hope that this webinar will give full information for us to in mitigating the disaster in Malaysia. So I think I also want to thank to our speaker for their valuable contributions and insights. So in the chat, the secretary already put email address if you have any questions, and if you want to know details about expand polymetric radar in Malaysia, also ask at dppc@utm.my. All right, I think I give back to Dr. Asna for the next session. Thank you, Dr. Asna.
Okay, thank you, Dr.
Thank you,
Dila,
Dr. Dila.
Prof. Adam, and also Dr. Sandi for today's fruitful discussion. I think we're almost to the end of the sessions. Okay, before we leave, okay, maybe there are two announcements. The first one, I really appreciate actually for today's guests can fill up the attendance form, because the Dppc actually look forward to contact you again and share more informations regarding our exploration in Dppc in X-band radar. And then number 2, we would like also to have a group photo together with the speakers. I hope all the guests do not mind to turn on the camera and we can have a group photo. Kila boleh tolong, Kila, can you help ni? Ke siapa the secretariat can help to capture the group photo. Okay, maybe we ask everyone to turn on the camera. Okay, don't forget to leave your information as well, so that the Dppc can contact you again if we have more sessions regarding X-band radar after this. Okay. Alright, siapa? Islah ke? Islah beritahu kita 1, 2, 3 ready.
Okay, 1, 2, 3. Right. Okay, thank you.
Kena pergi next.
Dr. Azna,
Yes.
do you mind? I have one message from Prof. Goto.
Oh, okay.
He asked me to send this. He said he have to go. Please say hi to everyone in the seminar. And actually he invited Prof. Miyamoto, but unfortunately Prof. Miyamoto cannot come in. So he said, very good webinar. That's
Alright, okay, thank you. And we actually plan to have another session with the Japanese expert as well, right, Dr. Dila, in future?
Inshallah. Inshallah.
Inshallah. Okay, we will share with all with everyone later if we manage to engage with the Japanese expert for this X-band radar. Okay, I think that's all for today. Thank you very much and hope to meet everyone again. So now I officially announce that our today's session is end. Thank you very much, everyone. We may dismiss. Thank you.
Thank you.
All right.
Thank you.
Thank you.
Thank you, everyone.
Thank you very much, Prof. Adam.
Bye.
Thank you. Permission.
Thank you.